Welcome back. So this is going to be a guide for power users. So if you've built up a bit of experience using LatheCam, I'm going to show you some tricks and tips to do a better job at LatheCam. So the first thing you might have noticed is we apply a lot of operations with the same modifications again and again. So let's have a look. We edit face. One of the things that you've seen as standard is we enable multiple passes and we set the step over to equal tool corner radius times 0.9. Now when you have a situation like this where you're applying the same set of modifications again and again, and same with the lead in and lead out, you can create something called a template. So the way that would work is you can right click on this and you can click store as template, and I'm going to call this facing for BIDC, and I can put in description modified the number of passes to be tool underscore corner radius times 0.9, modified lead out lead in to be 90 degrees, modified lead out to be 45 degrees, and make sure you save it to your local and hit save. Now what that does is whenever I need to do a facing operation, whichever cam, I can just right click, create from template, and I will have my template right here, and it's going to have the same tool as the one I used, and all I really need to do is change the tool. So for example, if I was using a C style, I just change the tool, click OK, and all the values update accordingly. So I no longer have to worry about setting these parameters individually one by one. As you can see, that's the new operation with a new tool, and then that's the old operation with a different tool, and you can see the difference in the corner radius, leading to a difference between the step downs. So bigger corner radius, bigger step down, smaller corner radius, smaller step down, and I didn't really have to do much other than selecting the tool. So templates is a great way for us to not have to do what I would call multiple times setting the same thing. I'm going to go ahead and hit delete because I don't really want this. The next thing is learning how to do grooves that are different than the groove width of the tool. So far all the grooves we have done have matched the groove width. So let's go ahead and modify, or actually look at what we mean by matching the groove width. Simulate. Utilities. Generate. Simulate. So what we have is this stock remaining. Turn off analysis, and I'm going to play. So we just have our tool come in, make our cut, and that's it. Now that's nice and easy when your groove width is the same size as your groove, but now we're going to look at when it's different. So we're going to increase the size of this groove. I'm going to isolate this one, and I'm going to modify one of the sketches. So I'm going to make this a lot bigger. Right now this is this value right here, so I'm going to go for 0.3 and finish sketch. Okay, now if I come back to manufacture, I'll have to regenerate. And if I now simulate, you will see that I am not able to make the entire groove. So the way you work around this, there are two strategies. The first strategy is to use single groove multiple times. So what I'm going to do is duplicate and come here and edit the second one, and instead of the top edge, I'm going to select the bottom edge, and instead of it being the back, it'll be the front now. So that should do the trick. And now I can simulate the entire thing and perform the first groove. That's the first groove, and then right below that I have the second groove. Now you can do this for any arbitrary length of groove. One problem you'll run into is when your groove is too wide, you can't just select edges, you'll in fact have to draw geometry to click on. So that can make it a little bit tricky, but otherwise it's about the same. Now let's look at another strategy where we don't use the single groove and we try to use our turning grooving to do the job. So I'm going to hit on turning grooving, and I'm going to have the same grooving tool selected, and I'm going to click OK, and obviously this will be right before part off. And now I need to define a few things. So the first thing I'm going to need to define is the start and stop. So it's not going to be all the way up in model front, it's going to be selection, and this is the front of the groove, and there's another selection for the back, and this is the back of the groove. Now let's have a look at what that does. So if I now try to simulate it, so does nothing there, does nothing there, does some work there, does nothing there, does nothing there. Okay, you see how that completely breaks everything and is in fact a collision. So let's try to fix that. Face. Now it's trying to start all the way from the outside, so we don't need that. We can keep that as model OD. It doesn't need to try and cut the stock. The stock's already been cut. And for the inside, we can go for a selection, and that's going to be this one right here. And we click OK. Now hopefully this better isolates, but let's see what happens. Simulate. There we go, there we go, there we go, there we go, and collision again. We're doing outside grooving, front to back. Geometry seems fine. Let's look at passes. I'm going to get rid of finishing passes and I'm gonna have roughing passes, and I have a couple of roughing patterns. I have full step down, partial step down, sideways with partial step down. I'm gonna go with full step down, and maximum groove step over. I'm gonna go with tool underscore groove width times 0.9. So that ensures I'm using 90% of the tool. Rough clearing passes. The red shaped area on the left represents that will be removed by rough. Let me disable this and see what happens. Okay, so let's have a simulation. Okay, I got that one. I got that one. I got that one. And there we go. So you see that I had to do a lot of work in order to get simple groove, in order to get grooving to work the way I want without crashing into my part. That is exactly why we try to avoid using grooving. But however, if you get comfortable with grooving and you set up some templates, you can use a groove, so you can do varying sizes of grooves without having to worry about adjusting everything. But there is a high risk for failure here, so if you don't pay attention to your simulation, you're going to look at a lot of collisions, and if those collisions make it onto the machine, you're going to look at a lot of tool damage. That is why I avoid doing grooving like that. Now another aspect we're going to look at is something we discussed while we were doing the OD operation that I wasn't particularly happy with. So I was happy with the facing. I was not happy with the roughing. So let's see if we can see that action where I was unhappy with the roughing, and that's where I was unhappy. So you see, the way it's approaching it, it's going to make contact with the back. And there as well. It makes contact with the back of the insert, which I don't like and can lead to insert breakage. The reason it's doing that is by the nature of this geometry. So there are a few things we can do to try and help alleviate some of this problem. The first thing we're going to try is we're going to try to create some geometry to make this a bit better. So I'm going to be here, and I'm going to perform a sketch. So I'll do a sketch, and I'll do a sketch here, and I'll try to project this point and this point here. Actually, I'll just try to project this point here. Click OK, and I'm going to come down here, and I'm going to try to match that up over there. This is going to be construction, and I'm going to ensure that these are perpendicular. So perpendicularity, there we go. And now I'm going to project this thing over here, and all I really want to do is find the center. So I got this point and this point. I'll go ahead and find right there X, and I'm going to make an arc. Let's try to go from here all the way out there. It's barely clearing. I think I set that distance to be too big. Command Z, 0.19, 0.18. So I pulled it off slightly, and now I'm going to make a line here. Now the key thing to know is the angle of this line. So it's 46 degrees. And this is a driven dimension, so I can see that this is 46.5 degrees. And I know that my insert is 35 degrees. So if I have an angle wider than that, it should not run into it when I'm doing my machining. So I'm gonna try my best to get that figured out. Let's go ahead and convert this into a 3D geometry. So I'm going to go to surfaces, and I'm going to do a revolve, and I'm going to have to select my profile, so it's going to be this right here, and I have to select an axis, which is going to be my x-axis, and I'm going to click OK. And I have just created a surface. Now the way you guys can distinguish this is if this is the surface I created right there, and this is the body disabled, so that's the surface I have created. It's a surface that I'm going to use as a guide when I'm doing my machining. Okay, so now I switch back to manufacture, and I modify the setup. I no longer want to use my component, I want to use my body. So I'm going to expand and click on the body, and as you can see, the body does not include the surface. I'm going to generate everything, and it should generate out pretty much exactly the same. Now when I come to my roughing strategy, I am going to modify this slightly. And under my geometry tab, I'm going to enable model, and it's loading. I'm going to give that a second. And I should be able to select my surface, cancel, edit, geometry, model. It's calculating the spun profile. I'll let it finish calculating. Let me just click OK and see what happens. No machine contour selected. Now let's see how that would apply. Close, edit. So I think it doesn't actually want us to select a body, it wants us to select a contour. So let me enable my sketch, and this is the contour I want it to select, and click OK. Okay, so now I can see the application. So all it really wants is a sketch. So I'm going to go ahead and make a few more modifications in my design. So I no longer really need this surface model, so I'm going to go ahead and delete that. And in my sketch, I'm going to go ahead and make some modifications. I'm going to get rid of all of the things I did, and I'm going to take an intersection. I'm going to intersect a body, so this is the body I'm going to intersect, and now I'm going to hide the body because I have an outline, and I'm going to do the same thing I did before. to make a line here and here, and I'm going to set this to be perpendicular to this, and I'll turn this into construction geometry. And now I'm going to make a line from here to here, and I'm just going to leave it on that arc, and it can be anywhere on that arc. If you see, there's a point which is right at the center of the arc, and now I'm going to start making some modifications. So the first thing I'm going to do is I'm going to trim. I'm going to just delete this, make this construction geometry, make this construction geometry, and I'll make an arc from center point starting here at that point and ending here at that point. And I'm also going to make a line across the center, and I'm going to make this a construction geometry, this a construction geometry, select all of this and construction geometry, and I'm going to make a line here, a line here, and that should give my rough profile that I wish to use. So I'm going to hit finish, enable my body again, come back to manufacture, generate again, and edit. It's missing some references, so I'm going to define my model. So let's hide the body, edit, yes, unselect and select, hide the body, start here, and click OK. Now I noticed something, that it's going into this groove. We had groove suppression, so let's see if we have to turn that back on. I do remember seeing a groove suppression dialog box, so let me check the finish profile. But if I turn on model, I see, so you see when we turn on model, groove suppression as an option goes away. So I need to modify my geometry a bit more. This is going to be a construction line. Edit sketch. And I'm going to make a line from here to there and finish sketch, and go back to manufacture, go back to generate, and here I'm going to edit, unselect my chain, and reselect. You can click on this, so that gives you a new chain, and I'm going to click add and click OK, and there we go. And similarly, I'm going to delete this one and create a derived turning finish, and I'm going to click OK. I'm going to put that right there. and lead out was modified. I'm going to take care of my lead out like I did in previous videos. Not the same. 90 degrees. Okay. Generate. And now we can hide the sketch and turn on the body and see what differences that made. So our facing works exactly the same. But now check out our roughing. Okay, it'll be advantageous if I slow this down. Okay, so now what I want you guys to see is there's a gap. I have created a gap, and I did all that work just to create that gap to save my insert from damage. And now this gap is there, and you machine it like that. You come finish it like that, and then you come rough it out like that, finish it out like that. You use your grooving operation, and then you use your part off. Exactly as the same as before. So as you guys can see that in cam, if we don't like the way something is working, we can usually get it to move exactly how we want. It's just a question of how much time and effort. And to be honest, this one is an edge case. If I was making one part, I would have probably stuck with what we did before. But if I was making 5 or 6 and I was working with a harder material, then I would go through this effort to ensure that the insert gets the best opportunity to survive the cut. Those are some of the power tools I wanted to show you guys. That's going to be it for the ST20 series, and I'll see you guys for the next one.